Hello and welcome back to this video series about the Intermediate Math League of Eastern Massachusetts. Today we're going to be finishing up the algebra section for Me Too, so let's get right into it. Alright, so the only thing we actually have to talk about today is unraveling word problems. It's the last part of Algebra Me Too, and it's because sometimes IMLEM will give you questions that you might know how to solve, but it's in the form of a word problem, so it's hard to figure out exactly what it's asking. So in these questions, it's going to give us a word problem, and we have to turn it into an equation so we can use our algebra skills to solve for a variable. I'll show you an example of what a word problem might be like. So this one says, Kate is 8.5 years younger than Caroline. In 5 years, Kate will be half as old as Caroline. How old is Kate? So when it comes to word problems, our first step is always to figure out what it's asking. So this question is asking, how old is Kate? So we're being asked to find the age of a person named Kate. Okay, well, since we're using algebra, and since we want to turn this into an equation that we can solve, we need a variable in our equation. And we always need a value for the variable that we're trying to solve for. So we're trying to solve for the age of Kate. So our first step is always to create a variable that represents what we're solving for. So I'm going to call that K. K is going to represent Kate's age. So K is the age of Kate. And that's what it's going to represent in the equations we create. All right, now if we continue reading the question from the beginning again, it says Kate is 8.5 years younger than Caroline. So your second step should be to stop here and notice that it says, then Caroline. It's talking about Kate's age relative to another person named Caroline. So since it's telling us that, our second step is always to create another variable representing any other people or any other values they put in the equation. So I'm going to call C the age of Caroline. So C is going to represent Caroline's age in this question. Caroline. And then if we continue reading the question, in 5 years, Kate will be half as old as Caroline. We see that nobody new gets brought up. So K and C for Kate and Caroline's age, respectively, will be the two variables that we're going to work with in this question. Okay, so now let's go back to the first sentence and try to create an equation based off that, because it's giving us information about their two ages relative to each other. So it says Kate is 8.5 years younger than Caroline. So if I were to try and create an equation out of this, it would look like this. C, Caroline's age, minus 8.5 equals K, because it's telling us Kate is 8.5 years younger than Caroline. So therefore, Caroline's age minus 8.5 years, or 8.5 years less than Caroline's age, should be equal to Kate's age, which is why I do C, minus 8.5 equals K. All right, so this is our first equation, C minus 8.5 equals K. But you'll notice that there are two unknown variables in this question. And we actually haven't seen much of that before. So it may make it difficult to actually solve for K and C. It's actually impossible for just one equation. But they also give us a second piece of information in the second question. In 5 years, second sentence. In 5 years, Kate will be half as old as Caroline. So if we try to create a second equation off this piece of information, it'll look like this. So in 5 years, so C plus 5, because this means 5 years later, or 5 years after Caroline's age, equals, and then K plus 5. And then we just need to make sure all the other parts of our sentence are in the question. So it says in 5 years, which I have represented here for Caroline's age and Kate's age, Kate will be half as old as Caroline. So therefore, if I do 1/2 times C plus 5, that should be equal to K plus 5. So why this works? Well, C plus 5 represents Caroline's age in 5 years. K plus 5 represents Kate's age in 5 years. And it's talking about how their ages will be related in 5 years, which is why I need both C plus 5 and K plus 5 in this equation. And it says in 5 years, which I have here and here, Kate will be half as old as Caroline. Okay, so therefore, if I multiply 1/2, or which is the same as dividing by 2, Caroline's age in 5 years, it'll be equal to Kate's age because Kate's age is half of Caroline's age in 5 years, which is why I have to put the C plus 5 and K plus 5 both in parentheses. And I actually forgot them here. Technically, you don't need to here, but you should in case you're going to move anything to the other side. Because when it comes to order of operations, you need to do the C plus 5 and K plus 5 first because it's representing their age in 5 years. Otherwise, it's going to mess up part of your equation. So now we have two equations, both with C and K in them. But we actually haven't learned how to use multiple equations to solve for one variable. So I'm actually going to jump forward onto the next slide and show you a new concept, and I promise I'll get right back to this. All right, so you'll notice I actually deleted the equations we came up with, so I'll rewrite them in a sec. But I have to explain one key concept first about how to use multiple equations to solve for one variable. And that's actually called using systems of an equation, or of equations. So here's an example of systems of equations. So this one is y equals 5x minus 9 and x over 2 equals y. So I have two equations here. I have two unknown variables here. It's kind of similar to the word problem we had. And I need to solve for at least one of these variables, because that's how you use systems of equations. You use multiple equations to solve for one variable when you have more than one unknown. And my unknowns are x and y. So here's how systems work. So this one is telling me what y is equal to. This is what you need to pay attention to. This one says y equals, and then it tells me what it's equal to. This one says x over 2 equals y. So if I flip this equation, for example, say I took the second equation, I could rewrite it as y equals x over 2. It's telling me what y is equal to. It's saying y equals and then whatever's on this side of the equation. Well, why is this important when it comes to multiple equations? Because if you look at both of these equations, and I accidentally just erased part of the second one, let me rewrite that. So if you look at both of these equations, this one, and this one's the same one, but I'm going to have you look at these two because they're more similar. You'll notice that they're both telling you what y is equal to. This one's saying y is equal to 5x minus 9, and this one is saying y is equal to x over 2. Well, if both of these are equal to y, 5x minus 9, and x equal over 2, and they're both equal to y, then I can say 5x minus 9 equals x over 2. Because y doesn't change. They're both equal to y, so therefore, they're also equal to each other. You see what I did there? I took the system of equations, or two equations, and I combined them and completely eliminated the variable y. Because they're both equal to y, so now I only have x in the equation. And now I can use this equation to solve for x. So if I use this equation to solve for x, first I want to get rid of this divided by 2 because I want x on this side. So if I multiply both sides of this equation by 2, I get 2 times 5x minus 9, and you have to multiply it by the entire side of this equation. So 5x minus 9 in parentheses, because you have to do that first, equals x, because x over 2 times 2 equals x. Now if I simplify my equation a bit, since I have 2 times 5x minus 9, I can use the distributive property to multiply this out. So 2 times 5x minus 2 times 9. This gives me 10x minus 18 equals x. All right, and now it's just a little bit of extra algebra where I have to get x on the side all on its own. So I need to get rid of this 10x, and since it's a positive 10x, I subtract 10x from both sides of the equation. So this gives me, on the left-hand side, negative 18 equals, and I keep this negative here since it's minus 18x, or minus 18, and on this side equals x minus 10x, which is negative 9x. And then finally, if I simplify this down, the negatives cancel out since they're both being multiplied by a negative number. And if I simplify this side by dividing it by 9, since it's 9 times x, and I want to get rid of this 9, then this just leaves me with x. And then when I divide this side by 9, because I have to do the same thing to both sides, this gives me 2. So therefore, 2 should be equal to x. So the entire idea of systems of equations is just to take your two equations and make it so one variable equals the other variable, but that one variable is the same in both equations when it's that equals something about the other variable. And then I can combine the two equations so I only have one variable left in them. That's what I did here. I said y equal to some values of x, or something done on the values of x, and then I combined the equations so I only had x in the equation. So if we go back to our other question, Kate is 8.5 years younger than Caroline. In 5 years, Kate will be half as old as Caroline. How old is Kate? So if I rewrite my equations, C equals 8 and, oops, that's wrong. C minus 8.5 equals K, because that's the 8.5 years younger. And then 1/2 times C plus 5 equals K plus 5, which is saying that in 5 years, Kate is going to be half as old as Caroline. Then now I have a system of equations. And it's not as easy as my other system, because with my other system, I had it equal to y already. But I can use the same idea here. I want to get rid of C, right? I need to solve for K, which is Kate's age. So I need to get rid of C. And the variable that we got rid of was the one that everything is equal to, which was y in this case. So now I need to make both of these equations. So it's C equals, and then some operations done on K. We'll start with the first equation. So C minus 8.5 equals K. Well, this one's really not that difficult. All you have to do is add 8.5 to both sides of the equation, because you want to get rid of the 8.5 on the left side. So you do the opposite operation of the same number. And then all of a sudden you have C equals K plus 8.5. All right, now if I do this to my second equation, where I have 1/2 times C plus 5 equals K plus 5. Well, this one is a little bit harder, I'll admit, but you just have to apply the same rules, where first I need to get rid of this 1/2, because this 1/2 is being multiplied to the parentheses. So I can't touch the parentheses until I get rid of everything outside of it. So if I get rid of the 1/2, that means I need to multiply both sides by 2, which is the opposite of 1/2. So if I multiply both sides by 2, it leaves me with, on the left-hand side, C plus 5 equals 2 times K plus 5. And if you look in the word problem, this also makes sense, because therefore, Kate's age in 5 years times 2 should equal Caroline's age in 5 years. All right, so now I just need to simplify, so I have C equals whatever's done on K. So I need to get rid of this plus 5, so I need to subtract 5 from both sides of the equation. So this gives me C equals 2 times K plus 5. And remember, the K plus 5 is in parentheses, so we can't touch that. And we can't touch the 2 times because we need to put this after. So minus 5. All right, so now that I have both of my equations equal just to C equals 2 times K plus 5 minus 5, and C equals K plus 8.5, what I can do is I can get rid of this C and set these two equal to each other, because they're both equal to C, and C doesn't change. So 2 times K plus 5 minus 5 should be equal to K plus 8.5. And now I have one equation with one unknown variable in it, and I know that I can just solve for K in order to find my answer now. So all I have to do is first pick a side where I want the variable to be on, which I'm going to choose the right-hand side because there's less things on it. So I need to get rid of this plus 8.5, okay? Well, in order to get rid of plus 8.5, I have to subtract 8.5. So if I subtract 8.5 from both sides of the equation, and I'm actually going to move up a little bit so I have some more room, this should give me 2 times K plus 5, and then minus 5 plus 8.5, or sorry, minus 5 minus 8.5 equals K. All right, so now that I have this, I just need to make sure to simplify the minus 5 minus 8.5. And if you simplify that out, I'm doing this quickly, it's going to equal minus 13.5. So now I have 2 times K plus 5 minus 13.5 equals K. All right, so my next job is to get rid of this K on the left-hand side of the equation. In order to do that, first I need to use the distributive property like this in order to solve this parentheses. So if I multiply 2 times k plus 2 times 5, that gives me 2k plus 10 minus 13.5 equals k. And it looks like I actually forgot an equal sign here. So I'm supposed to have an equal sign there. Okay, so now all I have to do is combine the plus 10 and minus 13.5, which gives me 3.5. So 2k minus 3.5 equals k. And now if I subtract 2k from both sides of the equation to get rid of this positive 2k here. So if I subtract 2k from both sides of the equation, so I can get rid of the k's on the left-hand side, then this gives me, oops, I didn't mean to put this equal sign here, then this gives me negative 3.5 equals negative k. And as I said, negatives on both sides cancel out if it's just multiplication. So since I can cancel out those negatives, now I have 3.5 equals k. So Kate's age, and if I solve this question, is 3.5 years old. And finally, I have a review question just to finish up the section. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll go ahead and explain the answer. So the correct answer to this question was 8 years old, and this was a difficult one. So let's go through it and find out how to find the answer. So it says, Jimmy, Bill, and Fred are all brothers. Okay, that's kind of useless because we don't need to know that. Jimmy is the oldest and Fred is the youngest. Currently, Bill and Fred's age add up to half of Jimmy's age. In 10 years, Bill and Fred's age will add up to Jimmy's age. If Bill and Fred are 4 years apart, how old will Fred be in 5 years? Okay, so like I said, the first step is always to figure out what the question is asking. And if we look at this part of this sentence here, it says, how old will Fred be in 5 years? Okay, so we're trying to solve for Fred's age and then just add 5 years to that. So since we need to know Fred's age, we should create a variable for Fred's age, which we're going to call f. So Fred's age will be represented by the variable f. All right, so now if we continue, or if we reread the question, we see that there are also 2 other people in this question, Jimmy and Bill, and they're talking about their ages relative to Fred's age. So therefore, we need to create a variable for both Jimmy and Bill's age as well. So if we create a variable for Jimmy and Bill's age, I'm going to call B the variable for Bill and J the variable for Jimmy. So now I have a variable for Fred's age, Bill's age, and Jimmy's age. And they're pretty easy to remember because it's F, B, and J. But if we look at the question one more time, there's actually one more variable that we don't need to, but we could create just to simplify up the solving a bit. Notice how it says Bill and Fred's age add up to half of Jimmy's age. In 10 years, Bill and Fred's age will add up to Jimmy's age. So it's talking about what Bill and Fred's age together add up to. And it mentions this more than once. And of course, we could represent this as B plus J. But it might come in handy if we just create one more variable to represent the sum of Bill and Fred's age, because it gives us this last piece of information. If Bill and Fred are 4 years apart, so if we know what the sum of their age is, we can use this last piece of information just to solve for each of their individual ages. So it might make it easier if we create a variable for the sum of Bill and Fred's age, which I'm going to call S, which stands for sum. All right, so now we have our 4 variables, Fred, Bill, Jimmy, and sum of Bill and Fred's age. So now we need to start creating our equations. So first it says Jimmy is the oldest and Fred is the youngest. This will come in handy later, but it's not a piece of information that we can create an equation off of. Currently, Bill and Fred's age add up to half of Jimmy's age. Okay, well I know that since Bill and Fred's age, which is S, add up to half of Jimmy's age, then that means 1/2 of Jimmy's age should equal S. So S equals 1/2 of J. All right, in 10 years, Bill and Fred's age will add up to Jimmy's age. All right, so in 10 years, which is S plus 20, and this is where you have to be careful with variables like this. It's plus 20 because we're talking about 10 years later, but it's for 2 people. So if we were to actually figure out what S means, remember it's B plus F. Well, if we were to represent that in 10 years, it'd be B plus 10. So Bill's age in 10 years plus F plus 10, right? So if we were to add 10 years, then it'd be S plus 20 because we're representing two people. So S plus 20, or the sum of Fred and Bill's age in 10 years will add up to Jimmy's age. Okay, so S plus 20 equals J plus 20 then, or J plus 10, because it's 10 years later after after Jimmy's current age. So now I have two equations. S plus 20 equals J plus 10, and S equals 1/2 of J. Well, I can create one more. If Bill and Fred are 4 years apart, all right, well, this is a piece of information. Even though it's in an if statement, it's a piece of information that I can create one more equation off of. They're 4 years apart, so therefore, F, since I know Fred is the youngest, so F plus 4, so 4 years above Fred, or 4 years added to Fred's age, since he's the youngest, will equal Bill's age. F plus 4 equals B. Okay, so now I have my three equations, right? And this is where it can get really difficult in systems of equations, because you need to know which ones to use first and which ones to save for later, because you can really only use two equations at a time when you're solving for specific variables. So I need to figure out which two equations to solve for first. And I need to trace back the steps on what I need to find from what it's asking me in order to do that. So it's asking me, how old will Fred be in 5 years? Well, the only equation that specifically has Fred's age in it is this one. And since I'm going to use this one then to solve for Fred's age with one other equation, then that means I can save this one for last. All right, so now I know I need to use these two equations first because they're the only two I have left. But I need to know what to solve for. Well, if I think about it, S is just representing Bill's age plus Fred's age, B plus F. And I could always break that back up into B plus F later. So if I solve for S, then I can use that with this equation. And if you're having trouble understanding exactly why I'm doing this, because I might not be explaining it super well, then don't worry. I promise you'll understand after I actually finish it. So if I want to solve for S in this equation, then therefore the variable I need to eliminate is J. I need to eliminate Jimmy's age out of the equation total. So I need to make it so J equals something done on S is the format of both of the equations. I need to get J all alone in both of these equations. Okay, well, I'm going to erase this over here so I have some more room. And I'm going to start with the first equation. It says S equals 1/2 of J, right? Oops, that's a capital J. Sorry, lowercase j. S equals 1/2 of J. So I just need to get rid of this 1/2. So I multiply both sides of the equation by 2, since 1/2 is technically divided by 2. And then it's 2S equals J. Okay, perfect. So I finished doing that for my first equation. Now I have to do it for my second. This one says S plus 20 equals J plus 10. And I just need to get rid of this plus 10. So I need to do the opposite operation of the same number, subtract 10 from both sides, and get S equals J, S plus 10, since plus 20 minus 10 is plus 10, equals J. There we go. S plus 10 equals J. All right, so now that I have my two equations, I can actually solve for the value of S, right? So let's see, 2S equals J, and 2S equals S plus, and J equals S plus 10. So therefore, 2S equals S plus 10. And now if I solve for S on its own, I'll choose this side since it's already isolated. I just need to get rid of this divided by 2, but I can also do that by subtracting S. So if I subtract S from both sides of the equation, because remember, I need to get rid of S on this side of the equation also, not just have it on its own on this side. And if I subtract S, it actually solves the problem for me. Now I just have S equals 10. All right, cool. Well, now that I know S equals 10, I can actually use this in this equation. So S is the sum of Fred and Bill's age. So if I do F plus B, which is the sum of Fred and Bill's age, and that's what S is representing, equals 10. Now I have one more equation that I created out of this in order to solve for Fred and Bill's age. All right, so this one is pretty simple. It's just some addition and subtraction. I want to solve for Fred's age and then add 5 years to it, since it says how old will he be in 5 years. So if I'm solving for Fred's age, then I need to isolate Bill's age on its own. That's already done for this equation. So I just need to do it for this equation. So in order to do that, I'm actually going to move this F over to this side, because I need to get rid of this F on the left side, and then the B, or Bill's age, will be all on its own. So if I subtract F from both sides of the equation, just remember this is a positive F. So if I subtract it from both sides of the equation, that gives me B equals 10 minus F. All right, so now I have B equals 10 minus F, and B equals F plus 4. So finally, I just need to combine these two equations to tell me F plus 4 equals 10 minus F. Since they're both equal to B, then I can set them equal to each other. All right, so lastly, I need to figure out which side to get F on its own on. I'm going to choose the left-hand side. So I need to get rid of this plus 4. I'm actually going to erase some of this stuff. All right, so I need to get rid of the plus 4, and in order to do that, I need to subtract 4 from both sides of the equation, so minus 4 and minus 4. And this gives me F equals 10 minus F minus 4. And I can actually combine the 10 and minus 4. This is a positive 10. And that would give me F equals 6 minus F. Right, now that I have F equals 6 minus F, I can just solve for F by adding F to both sides of the equation. Right, and this might seem like it's a bit unsolvable, but it's actually not. I just need to get rid of this minus F on the right-hand side. So I add F to both sides of the equation, plus F and plus F. And this gives me 2F, since now I have 2 F's on the left-hand side, equals 6. And then I just need to get rid of this times 2, since I isolated F now. And I get rid of this times 2 by dividing both sides of the equation by 2. And if I divide 2F by 2, that gives me F. If I divide 6 by 2, that gives me 3. And now my equation reads F equals 3. So Fred's age is 3 years old. And then it says, and you need to be careful to make sure to read this, because I did this all the time in IMLEM. I always forgot to read the question and read what it's asking. It says, how old will Fred be in 5 years? So if I take Fred's age and add 5, then that gives me 3 plus 5, and 3 plus 5 is 8. In 5 years, Fred will be 8 years old. All right, and finally, just to review what we've learned this lesson, we started by talking about unraveling word problems, where we looked at an example of a word problem. Kate is 8.5 years younger than Caroline. In 5 years, Kate will be half as old as Caroline. Then it asks, how old is Kate? And we learned that in order to solve these questions, you need to create equations based off the information given by creating variables representing all the different values in the question. So we created a variable for the age of Kate and a variable for the age of Caroline, and created 2 equations based off the pieces of information given in this question. And then before we actually solve the question, we need to learn one key concept, which is how to use systems of equations. So systems of equations are when you have multiple equations with the same variables in them. So this example had y and x in 2 different equations. And the way that you solve systems of equations is isolating one variable, so you have the same variable equal to some operation done on the other one in both equations, and then getting rid of it completely by setting these 2 equations equal to each other. So in this example, since they're both equal to y, I can set x over 2 equal to 5x minus 9. And then that eliminates one variable, and you can just solve for the variable that's left. So we looked back at this question, and we figured out that if we used our 2 equations and got rid of the c variable, so we could solve for k, then we'd be able to find Kate's age. And then finally, we did a review question. We were talking about Jimmy, Bill, and Fred's age. Well, we actually had 3 different variables, and we created 3 different equations. And then we isolated the variable for Fred's age and found that in 5 years, Fred will be 8 years old. That's all for today's video. This is actually the last video in the section for Meet 2. I hope you enjoyed it. I did my best to explain these concepts. Algebra has always been the most difficult subject for me, especially to do and then explain. So I really hope I explained these concepts well. They're very difficult, and I hope this helped.